Black holes are dense and scary. They suck up everything in their way. Their gravity is so strong it bends light and warps time. But what if I told you we might have been wrong about these cosmic vacuum cleaners? Well, for one, they're not vacuum cleaners at all. Black holes don't go around gobbling up everything in their vicinity. You'd have to cross a black hole's event horizon to get sucked into one. The event horizon is the area around a black hole where its gravity is so strong that you'd have to move at the speed of light to escape it. And moving that fast is simply impossible, at least according to Einstein. That's why there's no escape after you cross this line. The extreme gravity would pull you in and then you'd disappear into the blackness of a black hole. Forever. But as long as you stayed on the safe side of the event horizon, you'd be completely fine. Now, if you had a bad day and ended up sucked into a black hole, it might not be as violent as you think. Despite a black hole's unimaginably massive gravity, it wouldn't instantly crush you like a can of soda. No, you'd experience something that scientists call Spaghettification. It's when a black hole stretches you into the shape of, well, spaghetti. If you were approaching a black hole feet first, your legs would get long and skinny before your head started to change shape. Once you crossed the event horizon, the stretching you'd experience would be extreme and painful. The black hole wouldn't crush you. Instead, it would rip your molecules apart. This whole spaghettification process would only take a few seconds, maybe a few minutes tops. Sorry, did I say it wouldn't be violent? Yeah, I take that back. This would really hurt. But the good news is you could still make a comeback. Just not in the same form as you entered the black hole. Yeah, you may have heard that nothing escapes a black hole, but that isn't exactly true. All thanks to Hawking radiation. Turns out, black holes have an interesting quantum phenomenon going on. At the very edge of a black hole's event horizon, particles are constantly forming. Some of them fall back into the black hole, but others escape this monstrosity's gravity in the form of radiation. Hawking radiation, to be specific. Over time, so many particles escape a black hole's event horizon that the black hole disappears entirely, like it never even existed. But it takes an incredibly long time for a black hole to evaporate like this. And unfortunately, you wouldn't be able to reassemble yourself from all those emitted particles. So I really wouldn't recommend jumping into a black hole. Especially not into a supermassive black hole in the middle of our galaxy. You see, there are different types of black holes. The most common ones are stellar black holes. They are the remnants of stars at least 20 times more massive than our Sun. And because they're so dense, well, their event horizons can be several kilometers in diameter. Supermassive black holes are monstrous. Unimaginably big. The most massive black hole scientists have spotted so far is located in the middle of Phoenix A galaxy. It's got a mass of 100 billion suns. Yeah, billion with a B. At this point, it's not just a supermassive black hole, it's a stupendously large black hole, or slab. Until recently, scientists thought the biggest supermassive giant was Ton 618, a black hole with 66 billion solar masses. But there's so much of the cosmos we haven't discovered yet, and maybe supermassive black holes can be much, much more massive than we could ever imagine. Scientists still don't know exactly how these cosmic monstrosities formed. And we've got no idea what happens when two of them collide, but it sure wouldn't be pretty for anything caught in between them. But at least we can still observe them to find out more. A black hole's gravity is so intense that even light can't escape it, but that doesn't mean they're the stealthy ninjas of the cosmos. They're very much visible, just not in the way you might think. Because their gravitational pull affects stars around them, astronomers can detect their gravitational effects. They can also see X-rays when something big falls into a black hole. That's because when matter is pulled to the point of no return, it heats up to intense temperatures. But the most mysterious thing about black holes is what lies on the other side. There are theories that black holes can be gateways to other universes. A black hole might be connected to another point in space and time through what's known as an Einstein-Rosen bridge. It's a type of wormhole, and a very unstable one. Now, scientists haven't found proof of that yet, but that doesn't mean it's not possible. What if we could use black holes as cosmic subways? Where could they take us? Could it be another reality? Another time? Well, while all of this is fun to think about, there's one big problem. Einstein-Rosen bridges are incredibly unstable. They could collapse on you at any moment, trapping you inside a black hole before you could reach your mysterious destination. And even if we were lucky enough to pass through that bridge before it collapsed, there's still no way you could survive it. The intense gravity and radiation would likely destroy you long before you popped out on the other side. Maybe one day we'll learn to travel through black holes, but for now, it's best to stick to exploring our own solar system. Hey, why not visit Titan, one of Saturn's most beautiful moons? Well, that's a story for another What If.